Hello, this is Mike from Fair Repair again. I've sourced a new device, but let us talk about a few seconds about my last video, because there was the question with the boost converter, and and I told that I understand it like that the voltage somehow is stored in the coil. Now I got a bit feedback, and you have corrected me in this way, that there is normally a diode after the coil. However, in this circuit of this laptop, and maybe even in any laptop motherboard I've looked at so far, I've never noticed any diode after the coil. So I strongly guess actually the second MOSFET does the job of the diode. Unfortunately, I cannot test it anymore because it is already sold, but it was very interesting to talk about this again, because I'm not an engineer, I'm just an amateur. So thank you for your feedback, and let's see what I have for you today. This is a nice Medion Erazer laptop. A really nice gaming laptop. Medion Erazer model X17805. A pretty massive, but nice laptop. But it is well, at least from outside, in really bad condition. Also, under the keys of the keyboard, it does not look really clean. So I had devices on my bench in better shape before. So well, let's try anyway. This device came in with no power. So let's grab the charger and check the voltage. 19.5, okay. Let's plug it in. Here. Okay. Come here. So, and oh, what is this noise? The surroundings. Oh my god. Not again. Not again a working device on my bench. What should I do? It smells really bad. I think I have to open it anyway to see what is going on here. So, battery is unplugged. Ribbon cable is unplugged. Memory is still available. So what was this bad sound here? Probably one of the fans. How can we check? Let's check from the side, like that. Yeah? Okay. Let me inspect the fans for a few seconds, so I can decide what we have to do here. You know what, I grab the benchtop piece. So, okay, something is wrong with one fan. And also there's something wrong with one key. However, keyboard is working. So what is going on with this fan here? It's probably just bad, maybe full of dust with some luck. Can be. How can we remove it? Can we even? We can't. We have to lift the whole heatsink. Okay, when we'll do so? Needs fresh thermal paste anyway, I guess. But well, we have to. Let's remove the heatsink. Careful. Okay. Pah. Wow. Got scammed. Do you see this? The 8 coils in a row for the GPU. In the middle, there is something. That's a hole. You know I'm a specialist for something like that. There is a face missing. So they probably have messed with the GPU. Wow. Wow. This is not cool. This is not cool, my friend. Just in case you're watching. So it shows picture, but the GPU is probably dead. Most likely. That's disappointing. This is what you can get on the local marketplaces here. eBay Germany and Kleinanzeigen Germany. This is what you get. And I told him I do YouTube videos. And he still did not care about that. Okay, my friends, new day, new luck. There is high chance that something is wrong with the GPU already, since this is supposed to be a power stage for the GPU core. We have 8 phases here. 1, 2, 3, 4, 5, 6, 7, 8. The most left 2 are for the memory of the GPU, and the other 6 from here to the right are related to the GPU core. And it is always a bad thing if there is something wrong with a MOSFET or a power stage, DrMOS, connected to a very low, high consuming power rail. So yeah, we have to check the GPU, but before we have to clear this here. So I put the board on the preheater and remove a few components, and then I try to make the result here a bit better. Okay, let's go. Look how bad it is. Look. Okay. Like that. Yeah? Yeah, this is proper burned. Okay. So this is what happens when you only do the half of the job. I have no words for that. Or does this look any good for you? Okay, let's try to clear the situation. So what do you think? Will it run? Let's see. I'm really curious. I want to test this board under load. Okay, my friends, I tried to do a Windows installation with graphics drivers and then doing a graphics stress test, and yeah, let's hope for a good result. So, surprisingly enough, the GPU is recognized, loads the driver and even does benchmarks, but very slow. I get something like 15 frames in 3D Mark, which is less than the half which I would expect here. So we have definitely an issue. Still, with some luck, it is some kind of current sensing for the GPU, which reports 100% load, because 3D Mark reports 100% load. For this reason, of course, the GPU won't run faster. However, we have a second issue, which is the battery. The battery is not getting charged, so we'll take a look whether we have an issue in the DC-in circuit with some luck, or whether it is just a bad battery. And if we have solved the battery issue, we'll check the benchmark again. And if still nothing, well, then we have to look around the GPU for the sensing. We have to get rid of the faulty fan. Yeah, and with some luck, it will function again properly. So yeah, let's see what we have here. So what is with our battery here? We have 0 volts. And when I plug the charger, I have an orange LED here, but only 0.8 volts. Yes, unplug the charger and voltage drops immediately to 0. Okay. DC-in MOSFETs are underneath the heatsink, so we have to remove it again. Pooh, it smells like hell. This is really bad smell. I don't like it. Okay, so here, let's check the MOSFETs. Who knows? Short between source and gate. And the second one is good. Okay. Yeah, let's replace the first MOSFET. Maybe another short here, no. Here, this is shorted. This is shorted between all three logic. Weird, why it is functioning. Okay, however, has to be solved, so we solve it. And then we'll check again. So, between source and drain, you see clear shorted, clear internal shorted, 1 ohms, okay? So then between gate and source, shorted. And between gate and drain, shorted, okay? So then the other one, source and drain, is good. Drain and gate is good. Source and gate, probably shorted. Yes. Because of this one. The first one is shorted. Let's have a look for a proper replacement. Is it N channel? I think so, no? Let's assume from the charging controller. Where is it? Oh, don't tell me it is this MPS IC. Please not here. BQ24781, which is which works with N channel. Okay, so we need a proper N channel replacement. So I find one on another gaming board, hopefully suitable. Yeah, this fits perfectly. So something is still not okay. Performance of the graphics card is better, but still not okay. And charging also still not working. No change, basically. Well, actually, I did forgot about the shorted MOSFET on the back. Here is a third MOSFET even, so we have probably 2 MOSFETs in parallel. Maybe I've even replaced the DrMOS MOSFET. So ready for the second attempt. Let's see. Point 5. Something happens now. 13 volts. I have voltage at the battery. 1 amps charging. So battery is charging now. Let's see how it behaves in the benchmark now. No. Still low FPS, like 40 frames per second right now, which is not suitable. So no luck so far. The battery is getting charged now, but very slow. I have a GPU which is very slow. So something is very wrong here, and yeah, we have to figure out what it is. Most likely something with the sensing. And hopefully it has nothing to do with our missing power stage here. I don't think so. But we'll see. We'll open for everything. Okay. Now I have to disassemble it again, and yeah, let's check it. And now I'm here checking the charging controller and the surrounding circuit. Can you spot the same with what I can spot already? Let's have a closer look. Here. What is that? Does this look like a nice current sense resistor? What do you think? Looks like someone was hungry. Looks awful. I want to replace it. And I did my homework already. So this is a visualization of what we have to restore here. We have, yeah, almost any pin on the right we have to restore, which is bootstrapping, VCC, it is a 3.3 volt supply. Then we have a current sensing line, we have the VTemp line, a sync line and a PWM line, a PWM line. And here we have to restore the B plus line, the 19 volts, which comes basically from here. And yeah, this pins here we have to restore. Here we have to rebuild our ground connection, and also here. These are our ground pads. And on the top we have the actual phase pins, 3 pins for the GPU core phase, and this is what we have to do on the top. We have also to reconnect the VTemp line inside of the layers here. This VTemp line here we have to recreate because it is cut. And I have even no connection to the DrMOS to the left anymore. It is not connected to the VTemp pins of the controller anymore. So yeah, this has to be restored too, and then yeah, we might be fine. and however it will be a lot of work. I will need some hours, I guess, and yeah, probably not economical at all, but you know me, I'll do it anyway. So yeah, let's see how it will end up. The first step will be to mask the exposed traces which we don't need anymore. So for this I use my Mechanic UV curing mask. So let's check whether all pins are soldered properly. So we have bootstrapping here, which is an internal pin for the DrMOS. Then we have VCC, which is a 3-volt supply. We can check for continuity with here, and we do have continuity. When the current sense pin here has continuity with the controller, then the V10 pin here. Yes, this is our V10 pin. So the top pin is actually our current sense pin here. and we do have continuity with the controller. And this is ground. Forgot, this is ground. And we do have continuity with ground. Ground is everywhere. Where is ground? Here. Here is ground, and we do have continuity. So, bootstrapping is fine, VCC is fine, current sensing is fine. No, this is ground, sorry. Ground is fine, current sensing is fine, VTemp is fine. Now we have a sync pin. Where does it go? I have no idea. Sync should have continuity with VCC. No. And here? No. What is with our sync pin? Where does it has continuity? No idea. Let's check with a soldered. I see this sync pant here. Where are you? I have no idea. The other side of the board. No, don't think so. Or, yeah, to this resistor here. Here's a resistor. This resistor has 2 kilo ohms. For this reason we don't find continuity. Let's check with this via. And we do have continuity. Okay, everything is fine till now. Okay, everything is fine till this point. Last pin is PWM, which has to be continuity with the controller. Let's check. And we do have continuity with the controller. Wonderful. Now we'll cover this area again and then open only this part which is necessary for our soldering. I'm pretty happy at this point. I did expect something not okay here, but yeah. But right now everything looks like it should be. Oh, 1 second. Looks perfectly fine, no? What do you think? Huh? Looks good, no? Pretty happy? It is not perfect, but it will be good enough. Okay? Good. Now it's more or less flat. Let's try to open this area carefully. One more cleaning. Okay. Let's see. Keine Ahnung. So the new DrMOS has arrived. The people who know me can already assume I always want to stay safe, so I have prepared them already with fresh solder. And the actual plan is to replace all 8 at once, at one step. Let's see how it goes. So preheated temperature should be good right now. I think we'll start with this one and from where we'll replace one after another. Okay, let's see. Okay. So this is how it looks like. Unfortunately, we have two issues right now. The first issue is my microphone just went bad, so I have to use the Logitech microphone instead. Sorry for that, and sorry for the maybe bad quality here. And the second issue is I have lost my tweezer for some reason, my blue tweezer. Yeah, however, this is how it actually looks like. Just look yourself. I'm so excited, so happy about this job. Everything went very well. This sits perfectly fine on its place. I have added a few capacitors for bootstrapping, and it's the main power rail here and here, and also replace the big capacitors here, and covered the exposed tracks here again with the mask, with the UV mask. And yeah, also I have checked again these pins here for continuity with the rails where they have connect to. And yeah, everything looks still fine. Here we have a small solder blob here, but this is no issue. The whole left side here is ground, so don't worry. I think we are ready to test. So I will assemble it now, and yeah, hopefully we can run some benchmarks with this device. So take a look. Take a look at that. Looks promising. Okay. And what do you think? Will it work or not? Let's see. And I don't have picture, I can't believe. Caps lock. Oh, it was not on. Okay. Ah, yes. I forgot that the keyboard backlight is always on after a CMOS reset. I just forgot about that. It wasn't even turned on. But now we have picture. So dirty, this poor device, so dirty. Okay, can you see something? Not really, huh? Also not better. Okay, let's try anyway. External mouse. Mouse is working. Graphics card is shown in Device Manager. Here, RTX 2070. So, and now let's try superposition. Here I had the issue with it doesn't run with more than 25 or maybe 30 frames per second. Temperature, CPU temperature is good. Okay, let's run the test. Will it explode? I hope not. Okay, it's loading and... oh, look at that. Okay, 1 second. 120, 130 frames per second. This is what we have tried to achieve. This is what we have tried to achieve, and it is stable. GPU temperature around 60. So 130 frames. This is wonderful. GPU temperature around 70 degrees right now. Utilizations 96%. Cool. 14,000 points. This is good. CPU temperature max was 91 degrees. Okay, this happens. It's a i7 9th generation. I know from experience it can be pretty hot. So let's run 3D Mark. This is so cool. It is working as expected. Around 40 frames per second, 50 frames even. Great. This is what I would expect from RTX 2070. But let's wait for the result. So results are incoming, and see, it is absolutely inside of the specs. This way you can notice. So we have 6,800, 900 points, and it is even slightly above the average. With the average is around 6,700 points. So yeah, this is a really good result. I'm pretty happy. So what does GPU-Z tells? Temperature, GPU temperature 74 max, 75 max. Yeah, 75 degrees. Load is good. CPU temperature was 89, 91 max. Okay, this is expected. Yeah, great. I love it. You see, it is not impossible to restore a complete IC on a place which is completely burned. Yeah, it is hard and not easy, it needs a lot of experience, but yeah, it is possible. And you see, it is working very well. Of course, I can't say this is an economical repair at all. How many hours did I need for that? 10 hours with everything. But yeah, it was to prove myself to prove the one who scammed me. This can be repaired, and yeah, it was a great challenge. I'm happy. Did I told I'm happy? Yeah, I'm happy. So I hope you are happy with this content. Next time, hopefully, the job will be a bit easier and not something like that. Although I like track repairs, but it shouldn't be a track repair in every case I have on my bench. So as always, thank you for watching, and see you next time. Bye.